Circuit breakers, including both miniature circuit breakers, or MCBs, and molded case circuit breakers, or MCCBs, are designed to protect electrical circuits from overcurrent conditions. These devices function by interrupting the flow of electricity when the current exceeds a predetermined level, thus preventing damage to equipment and reducing the risk of electrical fires. Circuit breakers typically have two terminals, one intended for connection to the line, which is the power source, and the other for connection to the load, representing the device or circuit being powered. The fundamental operation of a circuit breaker involves allowing current to flow through it from the line terminal to the load terminal under normal operating conditions. When an overcurrent situation arises, the circuit breaker trips, effectively disconnecting the load from the power source. The question of whether a circuit breaker can be fed from either side is a common one, and the answer is generally yes. For both MCB and MCCBs, the design allows for power to be supplied to either terminal without affecting the breaker's ability to perform its protective function. This is because the internal mechanism of the circuit breaker is designed to respond to overcurrent regardless of the direction from which the current originates. In alternating current, or AC circuits, the polarity is generally not a critical factor in the operation of circuit breakers. AC power is characterized by a constantly changing direction of current flow alternating between positive and negative. This means that the current will flow in the same manner regardless of which terminal is connected to the line and which is connected to the load. Therefore, in most AC applications, it is permissible to feed the circuit breaker from either side. However, there are important considerations to keep in mind. Firstly, it is always advisable to consult the manufacturer's instructions for the specific circuit breaker being used. Some manufacturers may have specific recommendations or requirements regarding the connection of the line and load terminals. These recommendations are often based on the specific design and features of the circuit breaker and should be followed to ensure proper operation and safety. Secondly, it is crucial to ensure that all electrical work is performed by qualified and experienced personnel who are familiar with relevant electrical codes and safety standards. Incorrect wiring or installation can create hazardous conditions and compromise the effectiveness of the circuit breaker. It is also important to understand the ratings and limitations of the circuit breaker. Circuit breakers are designed to handle specific voltage and current levels, and exceeding these limits can lead to failure or damage. Therefore, it is essential to select a circuit breaker that is appropriately rated for the intended application. In addition to the above considerations, it is also important to be aware of the different types of circuit breakers available. MCB are typically used in residential and light commercial applications, while MCCBs are used in larger commercial and industrial settings. The choice of circuit breaker will depend on the specific requirements of the electrical system and the level of protection needed. When installing a circuit breaker, it is important to follow a few key steps. Firstly, ensure that the power to the circuit is turned off before beginning any work. This will help to prevent electrical shock. Secondly, carefully identify the line and load terminals on the circuit breaker. If there are any markings or instructions, be sure to follow them. Thirdly, connect the wires to the appropriate terminals, ensuring that the connections are secure. Fourthly, once the wiring is complete, turn the power back on and test the circuit breaker to ensure that it is functioning properly. This can be done by creating an overcurrent condition and verifying that the circuit breaker trips. It is also important to regularly inspect circuit breakers to ensure that they are in good working condition. Look for any signs of damage or wear, such as cracks, discoloration, or loose connections. If any problems are detected, the circuit breaker should be replaced immediately. In summary, while it is generally permissible to feed a circuit breaker from either side, it is important to consider the manufacturer's instructions, the type of circuit, and the specific requirements of the application. By following these guidelines, you can ensure that your electrical system is properly protected and that your circuit breakers are functioning safely and effectively. To further elaborate on the technical aspects, consider the internal workings of a typical circuit breaker. A circuit breaker's primary function is to interrupt the flow of current when an overcurrent or short circuit condition is detected. This is achieved through a combination of mechanical and electrical components. Firstly, there is a bimetallic strip or an electromagnetic coil that senses the current flowing through the circuit breaker. In the case of a bimetallic strip, the strip is made of two different metals that expand at different rates when heated. As the current increases, the strip heats up and bends. When the current exceeds the rated value, the bending of the strip triggers a mechanical latch that releases the contacts, interrupting the circuit. For electromagnetic coil-type circuit breakers, the current flows through a coil, creating a magnetic field. The strength of the magnetic field is proportional to the current. When the current exceeds the rated value, the magnetic field becomes strong enough to attract a plunger, which in turn releases the mechanical latch and interrupts the circuit. Secondly, the mechanical latch is the critical component that holds the contacts closed under normal operating conditions. When the sensing element, either the bimetallic strip or the electromagnetic coil, detects an overcurrent, it triggers the release of the latch. The latch is designed to provide a quick and reliable release, ensuring that the circuit is interrupted as quickly as possible. Thirdly, the contacts are the points where the electrical circuit is connected and disconnected. They are typically made of a conductive material such as copper or silver alloy. When the latch is released, a spring-loaded mechanism forces the contacts apart, creating an air gap that interrupts the flow of current. The contacts are designed to withstand the high temperatures and electrical arcs that can occur during an overcurrent event. Fourthly, an arc chute is used to extinguish the electrical arc that forms when the contacts are separated. The arc chute is typically made of a series of metal plates that are arranged to cool and dissipate the arc. The arc chute helps to prevent the arc from damaging the circuit breaker and from spreading to other parts of the electrical system. Fifthly, a trip indicator is a visual indication that the circuit breaker has tripped. The trip indicator may be a colored flag or a mechanical lever that is visible on the front of the circuit breaker. The trip indicator helps to quickly identify which circuit breaker has tripped, making it easier to troubleshoot and restore power to the affected circuit. When considering whether to feed a circuit breaker from either side, it is important to understand that the sensing element, the mechanical latch, and the contacts are all designed to operate regardless of the direction of current flow. This means that the circuit breaker will trip and interrupt the circuit whether the overcurrent originates from the line side or the load side. However, it is important to note that some circuit breakers may have specific markings or instructions indicating which terminal should be used for the line and which for the load. These markings are typically intended to ensure proper operation of additional features, such as surge protection or ground fault protection. In these cases, it is important to follow the manufacturer's instructions to ensure that these features function correctly. Furthermore, it is important to consider the wiring configuration and the grounding system when installing circuit breakers. The wiring configuration refers to the way in which the conductors are connected to the circuit breaker and to the load. The grounding system refers to the way in which the electrical system is connected to the earth. Proper wiring and grounding are essential for ensuring the safety and reliability of the electrical system. Incorrect wiring or grounding can create hazardous conditions and compromise the effectiveness of the circuit breakers. In addition to the above considerations, it is also important to be aware of the different types of overcurrent protection devices available. In addition to circuit breakers, there are also fuses, which are another type of overcurrent protection device. Fuses are designed to melt and break the circuit when an overcurrent occurs. Fuses are typically less expensive than circuit breakers, but they must be replaced after they have blown. Circuit breakers, on the other hand, can be reset and reused. The choice between circuit breakers and fuses will depend on the specific requirements of the application. Circuit breakers are generally preferred in applications where frequent overcurrent events are expected, while fuses may be more suitable for applications where overcurrent events are rare. When selecting a circuit breaker, it is important to consider the following factors. Firstly, the voltage rating is the maximum voltage that the circuit breaker can safely handle. The voltage rating must be equal to or greater than the voltage of the circuit being protected. Secondly, the current rating is the maximum current that the circuit breaker can carry without tripping. The current rating must be less than the ampacity of the conductors being protected. Ampacity refers to the current carrying capacity of a conductor, as specified in the National Electrical Code, or NEC. Thirdly, the interrupting rating is the maximum current that the circuit breaker can safely interrupt. The interrupting rating must be greater than the available fault current at the point of installation. Available fault current refers to the amount of current that would flow in the event of a short circuit. Fourthly, the trip curve is a graph that shows the time it takes for the circuit breaker to trip at different levels of overcurrent. The trip curve should be selected to provide adequate protection for the equipment being protected. Fifthly, the type of circuit breaker is another important consideration. There are several different types of circuit breakers available, including standard circuit breakers, ground fault circuit interrupters, or DFCIs, and arc fault circuit interrupters, or FCIs. Standard circuit breakers provide protection against overcurrents and short circuits. GFCIs provide protection against ground faults, which occur when current leaks to ground. FCIs provide protection against arc faults, which are dangerous electrical arcs that can cause fires. The type of circuit breaker selected will depend on the specific requirements of the application and the level of protection needed. When installing circuit breakers, it is important to follow all applicable electrical codes and safety standards. The NEC provides detailed requirements for the installation of circuit breakers, including requirements for wiring, grounding, and overcurrent protection. It is also important to follow the manufacturer's instructions for the specific circuit breaker being installed. Incorrect installation can create hazardous conditions and compromise the effectiveness of the circuit breaker. In addition to the technical aspects, it is also important to consider the practical aspects of using circuit breakers. Circuit breakers are designed to be easy to use and maintain. They can be reset simply by flipping the switch back to the on position. However, it is important to investigate the cause of the trip before resetting the circuit breaker. Repeated tripping of a circuit breaker is a sign that there is a problem with the electrical system that needs to be addressed. It is also important to regularly inspect circuit breakers to ensure that they are in good working condition. Look for any signs of damage or wear, such as cracks, discoloration, or loose connections. If any problems are detected, the circuit breaker should be replaced immediately. Proper maintenance and care of circuit breakers will help to ensure that they provide reliable protection for your electrical system. In conclusion, while it is generally permissible to feed a circuit breaker from either side, it is important to consider the manufacturer's instructions, the type of circuit, and the specific requirements of the application. By following these guidelines and adhering to all applicable electrical codes and safety standards, you can ensure that your electrical system is properly protected and that your circuit breakers are functioning safely and effectively. Furthermore, understanding the internal workings of a circuit breaker, the different types of overcurrent protection devices available, and the factors to consider when selecting a circuit breaker will help you to make informed decisions about your electrical system. Proper installation, maintenance, and care of circuit breakers are essential for ensuring the safety and reliability of your electrical system.